Hey guys, this is Ron. So up to this point, we've talked a lot about different data types and how to use those data types, but we haven't really got into the meat and potatoes about how to put your program together. So one aspect of that is to be able to define a function. And the reason we're going to do that is because maybe we want to perform some procedure multiple times throughout the life of our program. However, what we don't want is to have to code this procedure over and over again. If it's something that we're going to do more than once, then maybe we need to start looking at it as packaging that up so that I only have to call that one thing and it's going to run this procedure and then send me back my results. And so we typically do that with functions. And so you could write your program from start to finish, and it's all one big, code block or however. But in reality, in order for your program to really grow, in order for it to be a little bit more efficient, it makes sense to break up what it's doing into smaller chunks. And again, we tend to do that through functions. And so through this tutorial, we're going to define a real basic kind of function, just so that you can get the feel for how to set it up, how to call it, how to get values back out of it, things of that nature. So let's imagine that our code, all it's going to do is take a word, and for each letter, it's going to break down that letter into its ASCII equivalent, right? So rather than write this one piece of code and have to rewrite it every time, we're going to define that in a function. So now all we'll ever have to do is call this function and pass it the word that we want it to kind of analyze, right? So let's go ahead and attack this thing. There's multiple different ways that we could do this, but we'll try to keep it simple here. So we're going to define, and now we need the function name. So we'll call this a word to ASCII. So a little bit long of a name. I just kind of wanted you to kind of see that I have some flexibility here to name it anything that I want. And so here we're going to input our word. All right. So I've defined a function called word to ASCII, and I'm going to pass it some type of variable, and then I'm storing that, or I'm passing it a value that gets stored in the variable called word. All right. So I will indent here so that everything that follows this is going to be indented from this def, so we know that it's part of this function. Okay, so let's think of what do we need to do for this word. Well, for the word, we need to break it down into its character equivalents, right? So every word is made up of multiple characters. So how are we going to do that? Well, we can break out our old for loop. So for L, which is going to stand for our letter, in word, right? So just like when we sent a list, the values that would get passed into here would be all of the individual values inside of that list. Well, when you pass a string in there, what you end up with is the individual characters here. So we'll just do a pretty simple print, and we'll put and we'll do something like that and that. So this is going to be our individual letter, and this is going to be ORed, if you remember that command. This converted characters to their ASCII equivalent. And let's see, did I get enough? Nope. It's still prompted me because I hadn't put the last bracket in there. So I ended up putting it down here and it ended it out. All right. So a little ugly there, but it still works. So what we should expect to see is if we call word to ASCII, and I'm going to pass it some type of word, we'll send it test. What we get is T equals 116, E equals 101, and so on and so forth. So by building this as a function, now I can call it over and over again. So word to ASCII, and we'll send it test2. And it does exactly as it's supposed to do, right? So now we've basically built in a mechanism that if I ever want this functionality, all I have to do is, again, call this function and pass it some type of value that I want it to run on. Now, obviously, this won't work if I send it the wrong type of value. So if I send it a 3, I'm going to get, an integer object is not an iterable. So it hit this point and crashed. If I send it with nothing, I'm going to get an error again, type error. Word to ASCII takes at least one argument, right? So again, you have to be careful how you build some of these, because again, if you call them in the wrong way, you're going to throw errors. But usually, if I wrote this, I know what to send it, and I'm going to trust that I've done some type of testing before calling this. But we could, if we wanted to, we can put some type of exception handling in here so that the program doesn't crash. Now, we'll talk about exception handling later, but what I want you to see is, again, it's real easy to build a function like this. It's clean, and then all I have to do from here on out is just call that function and pass it a value. Now, what happens if, let's say I want to define subtype of default here. So let's say in the case here where I didn't pass it, I want it to still do something, but using some type of default. So we'll redefine our function. Let's go here. I'll copy this. And we had word, but instead of doing a word that and closing it out, we're going to do word equals, whoops. So this is like I forgot to pass it something I needed, right? And so we'll just do exactly like we did before. We had our for loop here. And then we had our print statement, all right? This time I'm going to remember my bracket. Now this time, if I arrow up, I can go back to my test. And notice it still does test2 just like it did before. But it also, if I don't pass it anything, will come up with the default. All right. So that's how we can set defaults into our program. Instead of just doing the single value here, we can do the value equals and then something there. So this will take over if you never passed in a value to begin with, right? All right, so that's cool. So that's how we use functions. Well, what happens if I want my function to do something and then return a value to me? So maybe I'm going to do something like this. I want it to square every value in my list and then return the sum of all of those things, right? So let's do something like this. We'll define, we'll call it squares and sums. And I'm going to pass in some type of list that we'll just call L. I know it's not very descriptive. And we have a couple different options here. We can square it and then sum it in place. We can square it, put it in another list, and then sum that list. There's lots of different options here. So what I'm going to do is I'm going to create a variable called the total, and I'm going to set that variable equal to 0. And then I'm going to do for x in L. So I'm getting the individual values that are in here. And then I'm going to do total plus equals. So this is like total equals total plus, right? So we're going to add to that x squared, right? And then once our loop is done, we are going to return total. All right, so let's try this out. Squares, oops, and sums. We're going to pass it a list of 1, 2, 3, 4, 5. And with any luck, okay, we got 55 back. So hopefully that actually equals 55. We'll send it just a 1. So 1 squared does equal 1. 2 squared does equal 4. 3 squared does equal 9. We had a 4 squared is 16, and 5. So if we have 25 plus 16 plus 9 plus 4 plus 1, we did in fact get 55. So that worked exactly like we wanted it to. It squared each one of these, added the whole thing together, and returned the value. So if I wanted to use that value afterwards, it's as simple as doing something like I wanted my total or my we'll just call it total equals squares and sums, and then I'm gonna put in 1, 2, 3, 4, 5. Oh, it's squares and sums, not squares and sum. So now total equals 55, right? So this is how we're going to send things into our function and return values from our function, right? So you just have to understand, if we're going to process some numbers, process, whatever, we have to have a return statement in here, right? So we're going to return this total, which is what we're totaling up here, right? And then that value that gets returned gets assigned to this total. And this could have been named whatever we wanted to. It just happens that I chose the same name, but it's a totally different variable. Once this function is done executing, anything that's in here as far as variables and what have it, they cease to exist. They only live for the time that this function is running, right? So the next time we come back in, space is going to be allocated for these new variables. This operation is going to be performed, and then it's going to get returned, and then Python comes in and basically deletes all of this, or garbage collects it, and so these cease to exist. And so these are only locally significant in the way that we're using them here. Now there's ways to access variables outside. It's not advisable, and unless your code absolutely has to do it, I recommend against it. But you can define global variables in here. I think you just put global in front of this, and then global total could reference a variable on the outside of here called total. But I would not recommend doing that. It's a whole lot cleaner and more advisable to do it this way, where these are locally significant, right? The scope that as you might call it, of these variables exists only within this function. And so as soon as this function again is done being called, those values cease to exist. The memory addresses that were allocated to them get thrown back into the system, and so it's a whole lot cleaner there, right? So Python cleans up after itself. Okay, so I hope you got something out of it. Again, not real advanced kind of stuff here, but you can kind of see how you can break your code out. You don't have to write something multiple times. You can write it one time and then call it multiple times. And so that'll save you some lines of code. It'll make your overall code a lot cleaner, a lot more simplistic, and it'll keep you out of trouble quite a bit. So again, hope you got something out of it. Thanks for watching.